Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
नहीं इसमें ब्लर कैसे Yeah, sorry. Yeah, hi everyone. I hope you guys can hear me. Yeah, so we are starting with the series 2 of the JavaScript interview question. So today the topic that we are going to discuss is, let me just quickly share my screen and then we'll get started. Yeah, so I hope you guys can see my screen. So we'll be using this editor for going through the questions that are generally asked in the interviews. So if I'm not audible, do mention it through the comments. So I'm keeping an eye on all the comments that you guys will be posting. So so today, like in the last session, we talked about a couple of questions related to the keywords that we use for including JavaScript, like async versus defer versus conventional JavaScript. We also talked about few core topics of JavaScript, like what is DOM manipulation, what kind of questions are asked generally from DOM manipulation side, and how can you create a UI using JavaScript. So what are the properties that JavaScript exposes, using which you can create a UI, or you can add an element, you can modify a particular element of the HTML. So those we discussed in the previous session of the interview series. And next we discussed about event bubbling versus event capturing. So I won't spend time on explaining these again. You can go through the previous session that we did on the MERN Stack interview series. Today what we're going to cover is we will talk about function currying. And it's a main important topic, I would say, because lots of questions are asked on function currying, especially related to there are some classical problems that are asked. What is that classical problem? So one classical problem is like you have to implement a function which is like sum, or it can be curry sum, that takes n number of arguments, or that takes one argument. But since in JavaScript functions are first class objects, right? So it can take, each function call will return a new function, and it keeps on doing till infinity, right? So how to solve these kind of problems, we'll see in some time. Like it will go on till infinity, and as you encounter a function call with no arguments at all, and that is where we need to terminate, and that is where we need to return the sum of all these numbers. Now there can be variation of this problem. Now here right now, each and every function call takes right now one argument, but it can take multiple arguments also. Like it can take 2, 3, so on and so forth. Like it can take hundreds or thousands or millions of arguments. So we need to think of writing a generic solution which can give us the sum of all these numbers towards the end. So that is one thing. So this is one problem. The first problem that I talked about was this, like where we are passing each one argument in each and every function call. The second variation of this problem could be where we are passing multiple or infinite arguments. So right now, the first problem is infinite function calls plus plus finite arguments. So let's remove all these dots. Second is Second variation of it could be infinite arguments and infinite function calls. 4. And it keeps on going until we encounter a parenthesis which does not take, or a function call which does not take any argument at all. So this is about infinite function calls plus infinite arguments. So that's about function currying. These are the two problems, and there could be multiple variation of it. But I would just give you an idea so that if there's any question asked, which is somewhat related to this concept only, but the operation that you're trying to perform within this question is right now addition, but it could differ to multiplication. It could differ to something else, right? It could be alternate summation or subtraction. It could, but it's a very important question from the interview perspective, because a lot of to evaluate a problem solving skills of a candidate on JavaScript side, generally these kind of questions are asked. Then I missed adding this. So there is one more question, like flattening in multi-dimensional array. This is also something which are generally asked. How you can flatten a multi-dimensional array. So you are given a multi-dimensional array, now an array containing an array, and so on. Right now you need to convert this array into a 1D array. So there are lots of things to cover right now, like in this second session of JavaScript, because from third session onwards we'll be talking about React and the questions that are asked generally from the interview perspective. So let's get started. So we'll start with the first question, which is flattening the multi-dimensional array, and then I'll touch base upon the topic called function currying and do a couple of problems on the function currying concept. Just give me 1 second. Yeah. So now let's talk about the first problem, which is this one, where we flatten the multi-dimensional array into a 1D array. So let's get started with this one. So what we need to do here is, as I said, you are given a multi-dimensional array. You need to write a function that converts this multi-dimensional array into a 1D array, right? These values should be converted into a 1D array. So how do you think of writing a solution like this? Because here the multi-dimensional array could be very huge. You don't know what is the depth of it, right? How many arrays are inserted in a nested way in a multi-dimensional array, right? So here, if you see, 0th index contains a value, first index contains an array, and in the first index it's an array, right? It's an array. In the first index there is an array, and in this array the first value is a value. At first index we have a value, at second index we again have an array, right? So that's how nesting is very in depth, right? So there is, like, if you see the depth of it, so this is the outer, this is the inner, this is again the inner, this is again the inner. So if you see, there are 9 or 10 level of depths in it. So how do you remove those depth and convert it into an array, which is a 1D array, one-dimensional array? Because every value in that array every index in that array contains a value, not an array. So that is what the conversion you have to do. So how to do that? So let's write a syntax for the function that we are going to use to flatten this multi-dimensional array. So what we'll do is we'll write a function convert to 1D array. Now in this, what we will do is we'll take an array. So you can write here multi-dimensional array, dimensional array. So there is a path to discover a solution. So we'll be going step by step so that you guys have a clarity on how I'm approaching this problem. Let me see if there are any questions related to the question, if people have understood this question or not. I'll talk about what is first class functions. So first class functions are nothing but, in JavaScript, everything is an object, right? So every primitive or a non-primitive. So every language has two types of data types. One is primitive and the other one is non-primitive. In primitive, you have inbuilt data types like number, string, number, string, undefined, null. So these are your primitive data types. In non-primitive data types, you have objects, arrays, functions. So all these are your non-primitive data types. So now, since we are saying everything is coming from an object, everything is an object. So functions can also be treated as an object in JavaScript. So you can, whatever you can do with a primitive type variable or a primitive type data type variable or a non-primitive data type variable, same you can do with functions also. Like you can pass them as an argument, you can return them from the function, or you can assign a different value to it. Or let's say you define a function and then you, using key value pair, you can assign one more key to it and assign a value to it. So what do we mean by first class functions? Is first class object is that they behave the same way how the other data types behave in JavaScript, because everything is coming from an object. If we are going to cover prototypes also, a slight bit of prototypes, so that you guys have an idea about what does prototype mean and how it does. So if you see in prototypes, everything is coming from the object. So your object is sitting on top. Then so let's say you use array, right? Just to give you an example, you use array. In array, you have access to a lot of methods, right? You have filter, you have reduce, you have array.toString. Now, toString is not an array method. It's not part of the array prototype. It's coming from the object prototype. So object has a method called toString. So it is coming from the object prototype. So how can you see that? Like if you open the developer tools, if you open the console, when you declare an array, this is how you declare an array. Now array gets access to all these methods that are there, right? So some of them are part of the arrays prototype. So these methods are part of the array prototype. And then some of the methods are not part of the array prototype, are part of the objects prototype. So when you do array dot underscore underscore proto, which is also called undo proto, you get access to the objects prototype. So if you see in the bottom, there is a prototype which refers to object. When you expand this, you will see certain properties of see toString is coming from object prototype. So I can very well access toString property which is coming from object prototype. So first, whatever property or whatever method you are trying to access, it will first look within itself, or any data type first will look within itself. And if it is not able to find within itself, then it will go to its parent. What is parent? Parent is object here, as you can see over here. So array.toString is also valid. It's not invalid. So when you do array.toString, it's valid. So you have converted an array into a string, right? So that is what I meant by first class objects, that in JavaScript, since everything, no, not that, that is what I meant by first class objects. That is what I meant by that everything is coming from object. So in JavaScript, functions also behaves like object only. So I hope that clarifies. I hope you're able to see my screen, right? We don't see, it's visible, okay. Yeah, so this is clear. Then we'll move on to the next topic, which is this problem. So how will we solve this problem? So we are getting a multi-dimensional array, right? So what we'll do is, in simple words, when we are getting an array, what we'll do, we'll traverse on that array, right? So we'll write the logic for traversing on this array. Let I equals to 0, I less than multi-dimensional array dot length I plus plus, right? This is the basic thing we can do, right? We can just traverse on that array. And how can we traverse that on the array? We can use a for loop, simple for loop. Now, when we use a simple for loop, what we have to do is we have to identify what is the type of value residing, what is the type of a value residing at a particular index, right? So array will have index, right? When you create an array, you have index. When you create an array, 1 2 3 4 5 6, right? This is your array, right? So at 0th index you have 1, at first index you have 2, at second index you have 3, at 4th index you have 4, and so on and so forth, right? So similarly here, I want to check what is the value that exists at that particular index, right? So what I'll do is I'll just copy this and I'll simply try to access this using PostScript notation. That is how you access the value residing at particular index. Then you want to check what is the type of it. So if we do the type of it, let's do the type of it, type of. Now when you do type of it, or simply we can do like this also. Let's just log it for now so that it's clear to everyone like why are we logging it and what is the type of each and every value stored at a particular index in this multi-dimensional array. Now let's call this function. In this console log I'm just doing for explaining you guys so that you guys have an idea that what each value corresponds to. So let's just copy this array and pass it as an argument. Once we have passed it as an argument, let's just run our code first. So when we run our code, you can see this loop ran for only once. The reason it ran for only once because there is only one value, right? Because when this loop was starting, this is the only value. Second value is an array, right? So it says type of first value is number, type of second value is an array. So it is saying it is terming it as an object, right? So when it is terming it as an object, so now my hypothesis, which I was trying to explain you, that everything in JavaScript is an object, right? At second value, it's actually not an object, it's an array. But since everything is in JavaScript is an object, that's why when we do type of this array, it prints as object, right? So if you print the index over here also, that will give you more idea on what value it's printing number and on what value is it printing an object. So see, at 0th index, it is printing number. So one is it at 0th index, and the first index, this is the value, right? This is the value that is getting stored. What is it? What is this value? This value is an array, right? But what is it? What is JavaScript interpreter, or what is this? When we run this program, what does this print? It prints an object, right? So our hypothesis holds true that everything in JavaScript is an object, right? That is what holds true. Now we've got to know that it's an object. Now, what should we do to remove the layers from this object or from this array, right? This inner array has layers, right? At every index, you have an array. At every index, you have an array. So how to get rid of those, how to get rid of this nesting? So what we'll do is, since we've got to know that at every index, on the first index, we have a value, and the rest of the index, we don't have a value. So what we can do is we check here if there is a method, right? Array is a you can say is a blueprint. When you write capital A array, it's a blueprint, or you can say a class, not class you would say, but it's a blueprint, or you can call it as a class also, which has access to all these methods, all those properties which would be coming from somewhere, right? JavaScript initially is a functional programming language. With the introduction of classes, you can also create classes, but you can assume that this is a blueprint from which all these methods are coming, right? So it has access to a property called array.isArray. Now, what we will do is we are checking array.isArray, then we are passing multi-dimensional array and its index. It checks if it's an array. Then what we will do is, now if it's an array, we need to compute it differently, right? So what we'll do is we'll use a recursion over here. Why we are using recursion? Because we can't do it iteratively. How many loops do we apply? Because there can be a nesting of millions of arrays or millions of elements. So we can't use loops, right? Because loops would limit us, because we don't know how many level of nesting is there in this multi-dimensional array. So that is why we are using recursion. I hope this is clear to you guys, because this is a very important point. Why we are using recursion, why we are not using an iterative solution. The reason we are not using iterative solution is because this nesting, this depth, the one which I'm highlighting, we don't know how much this depth is going to be, right? If we know how much this depth is going to be, then we can use a iterative way, like we can write nested for loops and do and convert it into this thing. But here we don't know how much this nesting is going to be. That is why what we are going to use is we are going to use a recursion over here, because this is not known. The best possible solution available to us is recursion. Use recursion here. So we have identified this is an array. Now we'll call convert to, we'll copy this so that we don't end up wasting time on writing this from scratch. So we'll copy this also, and then pass the value which is stored at that index. What is the value? This is the array. This we are passing. This we are passing again to the convert to 1D array. Now, if it's not an array, what do we need to do? We need to store the value somewhere. So where should we store the value? Now, one way is we can create a local variable, but if we create a local variable, then that does not make sense, right? So instead of creating a local variable here is we can keep a global variable for now. We'll name it as output. And inside the output, I'll keep on pushing the values, which are actually the values, not the array, right? So see, at 0th index, we have first. So this should be inserted. This condition will be false. It will go in else, and it should push it into my output array. So it will push it into my output. I'll do output.push, and it will do output.push, and we will push the multi-dimensional array I. Right. So I think this much of code would be enough to convert this into a 1D array. Now let's try running this because it. Now let's try running this. How should we run this? Since this output array is getting modified inside this convert to 1D array. Now what we can do is we can once this is over, either we can return an output. Either we can return this output because this output is getting modified from here. When we return this output, what we'll do is we will simply log the value here from where we are calling it. When we do that and when we run, you can see we are getting a 1D array. Now we are getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as a 1D array, right? I hope this clarifies and this is clear to each one of you what we have done here and why we use recursion here. Now, another way I would give this to you as an assignment. I'll give you an idea like what you can do is to see global variables are avoided. At any cost, you should avoid using global variables because it adds an unpredictability to your program, right? You don't know from where the value of global variables can be modified. So to avoid that unpredictability, we should move this global variable into local variable. But since we are using recursion, so if we move this here, what will happen is when we call recursively this program, what will happen? The control will come here and then again it would be initialized. That we want to avoid, right? So to avoid this, we can use the closure concept. How can we use? We can create an outer function and assign this, create this variable. And once we have created closure, we would be able to leverage the local variable instead of leveraging the global variable. So that's what you can do to make it local. And this is a follow-up question also, like how can you convert it into how can you avoid using global variable and use a local variable? So that's how you can do it using closures. So I hope that clarifies and that should be clear to each one of you. Let me see comments if there are any questions. Are you able to see my screen or it's you're not able to see my screen? Hazard 30 US, can you see my screen or is it still not loading up for you? Are you there in the call or? Anyways, I hope you are able to see my screen because that's why you're not responding. Yeah. So let's move on to the next question. So first question is done, like how you can convert a multi-dimensional array into a 1D array. Next question is basically also again on the very common topic, which is this curry sum. Here also we'll use, now there are two variations of it which we are trying to do over here in this session. Like one is infinite function calls plus finite arguments. Second one is infinite function calls plus infinite arguments. So this is a question which has been asked in a lot of big tech companies like Walmart, if you're appearing for front-end interviews or if you're appearing for full stack JavaScript-based interviews. A lot of companies have asked this question. Like I myself has encountered this question in lots of interviews in companies like Walmart, Swiggy, Microsoft, Repling, and all. So it's a very common question and a very classical front-end problem. Have been asked. You might, if someone is giving the front-end interview, like in the recent times or times to come, I would advise you to go through this problem and go through this video also, because I'll try to explain you in depth like how we can implement this kind of a problem. So what we'll do is we'll just copy this snippet. I'm not removing the code which I've written for the previous problem which we discussed. I'll write the problem here. So what is that? What is the problem? So since in JavaScript we say that, so this is also called, this concept is also called function currying. So in function currying, we basically leverage the concept of higher order function. What is higher order function? Higher order functions are nothing but, let's say you have a function here, function A. Now inside that function, you just log some value. Let's say we are logging this. Now this will always obviously be pointing to window object here. Now, since we are running it on Node, so it won't be pointing to window object, it will be pointing to global this. Now we create a new function, HOC. In that, we are passing this function as an argument. Now from this function, which is HOC, or not HOC, we can call it as HOF. From HOF, we basically invoke this function, which we are passing as an argument, right? When we pass this as an argument, what we'll do is HOF, when we call HOF, what will happen is, since from HOF we are trying to invoke this function, we'll pass this argument A. Now this function is called your higher order function because this takes a function as an argument, right? And whatever function we are passing as an argument is called a callback function. So this is your callback function. This is your callback function. So on the basis of this concept only, it adds a lot of reusability to your code. You can basically bifurcate logic, or you can, if you have a very complex problem, you can break it down into smaller sub problems, which you can individually solve upon, right? So here also in this problem, what we are doing here is, here simply you're just calling the callback function, but here we don't call, like we will call eventually, but we will call from outside, not from inside. So we'll just simply return this function, and we'll call the return function, right? Like this. We'll just simply return this, and from here we'll try to invoke it like this, right? And we'll keep on doing. So since this is an infinite series, so we'll keep on returning a new function, and we'll keep on invoking from outside the body of the function. So that's what we are trying to do in this problem. I hope this clarifies like what is higher order function, what is callback function, and on what concept this problem is based upon. So this problem is based upon function currying, and it leverages higher order function properties, where you can reuse certain code or certain logic which you don't have to repeat yourself, and can use to solve complex problems by breaking into some smaller sub problems. So that's what we are going to look at now. Let me just comment this, and let's start writing the code for this one, curry sum. Now in curry sum, what we'll do is we'll see two variations of it. So first variation is like you have one argument being passed, 2, 3, 4, 5, 6, and we'll add like a couple of dots, or right now let's not add dots, we'll add few more, 8, 9, 10, 11, 12. I'm not add dots. Let's stop here only. So what we'll do is we'll write this function called curry sum. So this is the function body we have written. Once this function body is written, what we will do is it takes our argument, right? What is that argument it is going to take? It's a number. We'll write num1, right? Now what we will do is we'll return a function, because that's how we are executing it, right? We'll return a function which takes another argument called num2. Now when it returns a function, we are invoking it here. Now when this function with 2 argument returns and another function, we'll invoke it with 3. Then again we'll invoke it with 4. We'll again invoke it with 5, and keep on doing it until we encounter an empty parenthesis. Now we can't write 12 times, right? Here like this, return function num3, return function num4. So this is not scalable, right? Because let's say if here it was written 1,000 times, or if here it was written 10,000 times, how could have we done it, right? We couldn't have done it, right? Because we can't write 10,000 times like 10,000 times like return function. We have to think of something where where we don't have to repeat ourselves again by writing the same function and the same argument it takes, right? So here also we'll use recursion. The reason of not using recursion, or of using recursion and not using any iterative solution is, with recursion, see here, when you use iterative solution, right? Sometimes in iterative solution, you know upper bound, right? You know what, till what value you need to increment or till what value you need to execute a function, right? Here, that upper bound is not known, right? Here you don't know what that upper bound is going to be, because each of these function calls are getting added here, right? Now you don't know how many function calls will be there after this. After, let's say, like there was 1 2 3, and after this there was 4. You don't know how many function calls can be appended after that, right? There can be 100, there can be 200, there can be 300, right? So you don't know what that value of going to be, what that value of how many functions will there be. You don't know that. So that is why we can't use an iterative solution. We have to fall back to a recursive solution here as well. So how to fall back to recursive solution, how to write recursive solution is something we look at. Let me see if there are any comments in this section. Yeah, so uh, we'll now we'll look at the solution. What this solution is going to be. So what we'll do is we will remove all these functions, and we'll just deal with the second function, since this is something on which we can apply recursion, right? So what we'll do is we'll check if the number 2 is defined, else we'll write an if else condition. If number 2 is defined, what we will do is, if it is not defined, see, if it is not defined, we'll simply return whatever value we have accumulated in number 1, right? If it is defined, here we have checked the condition of not defined. So not defined we are using, like, if there is an empty argument, right? Empty argument means undefined. And when you do a not of undefined, you'll get a value truth, you'll get a true value, right? When you get a true value, you simply return the number you have accumulated so far. When you get a falsy value, you don't return that number. You keep on doing it, because when you do a not of number or not of defined value, then you will get false here. When you do not of undefined value, then you will get a true here. So that's why this condition will become true and you will return the value. Now here we need to go to recursion. So how will we go to recursion is, we'll call the outer method, whose name is currysum, and we'll do num1 plus num2. Now, this is the piece of code that you have to write to implement this problem. So what we have done here, again, I'll reiterate what we have done here is, we have defined the function, we have defined the inner function, and now we are trying to call it recursively. So first we'll check if num2 is defined, then we'll go into the else part. In the else part, what we are doing is, we are calling this currysum method with num1 and num2. Why we have added a return function is, we need to return this also so that we can invoke. Also, right? If we don't write return, then the invocation would become a problematic scenario for us. So what because we have to return so that it does not execute the other piece of code. So that's why we are returning over here. So what is happening is, it returns and it calls the other function. So it started with 1. Then when it summed up over here, like num1 and num2 value, it became 3. Then again it was called with 3, it became 6. Then again it was called with 4, it became 10. Again it was called with 5, it became 15, and so on and so forth. Now when you run this, let's run this for now. When you run this, I think there is some issue with the code, because there's the output variable I have not defined. So you can see you are getting an output of 78. So this is the output which this currysum is printing. This is the output which this currysum is printing. Let's say if we add few more arguments, then also this solution will work, because this solution is pretty scalable. Right, now when we run this, we need to define one empty parenthesis. That's what we have not defined. When we run this again, we are getting 197. So here what we have done is, we are just checking. See, we call this function. Now this function returns in another function which is invoked with the second argument, right? Now in that we check whether second argument is defined or not. If second argument is defined, we recursively call this with the sum of num1 plus num2. So here it in the second time it will be called with curry sum of 3. Here num1 would be 3. Then again we return a function with which we are invoking 3, invoking with 3, and then again we recursively call curry sum and keep on doing this until we get the last argument, which is an empty parenthesis where this condition will true. And why we are returning num1? Because num1 will hold our final answer. That is why we are returning num1. So this is the solution for this problem, and this can be extensible to, this can be scaled to n or n number of n number of function calls and n number of values. Now when we say n number of function calls, so here the number of functions calls are not, we don't know how many function calls could there be. Like right now there are 15 or 10. I can write 20 also, 30 also, 40 also. It does not, we don't know how many would that be. So that is one one way of solving this. Now I hope this is clear to everyone. Let me see if there is any questions on the chat. I don't see any question on the chat, so let's move on to the next problem, which is a variation of this problem. Right now, we have fixed argument. Let's say, what if we have infinite arguments in each and every function calls? Like let's say at 2, 3, 4, 5. Here also 2, 4, 5, 6, 7. Here also 3, 7, 8, 9. How will we solve this? So we just need to tweak this code, and we'll be able to solve this this problem also. 10. 9, 11, 14, 15, 17. Right? So this is like number of arguments to each and every function call. We don't, it can be huge, right? So we don't have to bother about how many are those and how many are those, how many are there. So how can we do it? Like right now we are taking num1. So what we can do is, since we are passing in a stream of arguments, it can be a stream of arguments, right? So we will use a spread operator to convert this stream into anything that is an iterable. Can be used with spread operator that will convert the iterable into an array or into an array of strings, depending upon what you are passing. So here we are passing the spread operator, and then we'll pass the args, or we can just write a. And similarly here we can have multiple arguments. We'll again use spread operator, and we'll write b over here. And then what we'll do is, since we have an A as an array, B also is an array. So what we'll do is, we'll use a loop, A dot length, I plus plus. Then we also need to maintain a variable here. So we'll again use a global variable. Now again, it's an assignment for you how to move this global variable into a local variable. So we'll do sum plus equals to A of I. And once we have that sum, we'll return this sum. And again, what we'll do is, when we have that array, we'll call the curry sum with a b, with the series of b values that we are getting here. So here, since we are getting b, we'll check if b is undefined. If it is undefined, the value would be true. We would end up returning sum. If b is defined, then it will go here. We are destructuring it. We are kind of destructuring it. When we are destructuring it, we are passing whatever arguments were there in b to a. Now, and we are then summing it up. When we are summing it up, sum will contain the sum of all the values that are there. So when we run this, I think there is one problem here. It will be return sum, curry sum. It returns a function. It does not return. So here it would be, if b dot length h equals to 0, Yeah, we are getting the value of all these. So if you count the values, like it would be again a waste of time, but the value would be obviously be 357. So that is how we can solve the variation of it. The only changes I've done is I've created a variable in which I'm collecting all the sum and I'm traversing on that array. Since I have converted it into a stream, the reason I've converted it into a stream is because the number of arguments are not known; they are infinite. So that's why I've converted them into an array or a list using spread operator. When I've converted them into an array or a list using spread operator, I'm using that to sum all these values. And once I've summed these values, I'm doing the same in the inner function. But inner function, I'm not doing sum. Inner function, I'm just passing whatever arguments I've collected in this whatever arguments have been passed to the second function call, which is the inner function call. I'm just passing it on to the parent function call because there only I'm doing the sum. So I've reused the logic which I have done at the parent level, not doing it again, right? So that way it returns me the final answer. So this is the variation of the second problem, which is a very commonly asked interview question. Now we'll move on to the couple of topics related to polyfills. So now what is polyfill? We'll talk about what is polyfill, but let me see if there is any question. Mayank, this is not a class where we are discussing which domain to pick, because here we are mostly discussing the questions on questions asked in any JavaScript interview, or questions asked in a MERN stack interview. So we have two-part JavaScript series, two-part React series, and two-part Node series. So here we are just discussing the question that can be asked in an interview on JavaScript side. So there's a second series. So I don't think I'll be able to help you with this answer. But yeah, try to focus on what we are trying to learn through this session, which is like what kind of questions are asked and how to solve those questions. So we have talked about all these types of questions so far. So we'll talk about polyfills now. I'll skip that question because that is something which is not related to what we are discussing in this session. So what are polyfills? Polyfills are nothing but we have different sort of browsers, right, on which our code executes. We have Chrome, we have Safari, we have uh, we have Opera Mini, we have IE Internet Explorer, we have Firefox. Now each of these browser, since they uses JavaScript V8 engine, right? Or see, Chrome uses JavaScript V8 engine, Firefox uses Spider Monkey, so they have a different interpreter that they use, or the engine that they use to basically execute the JavaScript, right? Now all of them have has support for different versions of JavaScript, right? So we have different versions of JavaScript that has been released by a body called ECMA script. This is the body which basically rolls out the versions or tells us the addition of new things that have been added onto the JavaScript side. Now, since there are different sort of versions in JavaScript, there are different sort of methods also that are available in JavaScript. Now, in the recent version of JavaScript, there were a couple of methods that are introduced in the array, like filter, map, reduce, and the spread operator, then object.assign, object.values, object.key. So these were the methods that are assigned in these. That are basically these are the methods that are part of the latest version of JavaScript, latest or the like ES6 or ES5 version of JavaScript, right? Now it can very well happen, like since Microsoft used to support Internet Explorer. Now and similarly Firefox is supported by, I don't know the parent company, but Opera Mini is supported by the company Opera. Safari is supported by Apple, Chrome is supported by Google. Now some browsers, let's say Internet Explorer, if you talk about, and the support for that has been discontinued. Like we are not actually supporting this browser. Microsoft is actually not supporting Internet Explorer that actively, but some chunk of people might still use that Internet Explorer as a browser, right? Now, if you come onto the Geeks4Geeks platform, and if you're coming onto the Geeks4Geeks platform, and if you are using Geeks4Geeks on a platform like Internet Explorer, then what can happen is we are using some method which is not there in the JavaScript version that we're using in Internet Explorer. Let's say I use array.map, right? Now array.map is in ES5 or ES6 version of JavaScript. I'm not very sure, but it came after ES5 or ES6. So now when you're using array.map, right? If it is not there in the version of JavaScript that is being used on Internet Explorer, then what will happen? Since we are using array.map, there is no method called map. So map is undefined. When you try to add the brackets or add the invocation brackets with the thing that is undefined, you will get a type error, because you are trying to use undefined as a function, which is not possible in JavaScript. So you will get unpredictability, right? So what you do is you write your own custom implementation of these methods, which are not there in browsers, which are not being maintained by the companies which have released them in past, right? So polyfill is nothing but it's a custom implementation of those methods or functions, or the methods or functions which is not there in that browser. So some, as I said, some browsers are on board on the latest version, some are not. So for those browsers which are not on board on the latest version of JavaScript, we make sure that we write polyfill for those or custom implementation for those, so that our code does not break. So one such example I give you of map. So we can write a polyfill for map. How do we write the polyfill for map? Is we'll use array. Let's say map is part of array blueprint or array prototype. Now what we'll do is array dot prototype dot, we'll provide the method called mymap, or I've renamed the map method to mymap. You can name it as to map also, but the idea remains same. Similarly, you can, if you want to implement for filter, you can change it to myfilter. But let's do it for map quickly so that I give you an idea, and later you can replicate it for other set of types that are there in there. Then here you will write function. Right, when you write function here, so there is one thing which I want to talk about is, like, when you write a function here, you will you need to, the reason we are writing this function, we are not writing arrow function, is because we also need to make sure that what is the reference with which this mymap method is being called. That reference is going to be an array, right? So that is why, to get that reference in this keyword, that is why we are using this function, not an arrow function. If we would have used arrow function, our this keyword would be pointing to the window object. So that, to avoid that, we are using a normal function or anonymous function here. So what we'll do is we'll simply do for let I equals to 0, I less than this dot length. What is this? As I said, this is the reference with which this function is going to be called. Now here I'll simply have an output. Now here also I'll have a callback, because this will take a callback, and in that output I'll simply do output dot push, and I'll pass CB, and in CB I'll call the callback. So CB is nothing but your callback function. I think I explained you what are callback functions. Callback functions are nothing which are being passed as an argument. Those are called your callback functions. So here it is being passed as an argument. So this will be called as a callback function. So we'll do this of I. We are passing the argument. Now we try to call this mymap method with some array, right? So we'll create an array, const arr 1 2 3 4. Now array dot mymap, right? Now in this we'll define this item. We'll multiply each and every index by 2. When I do that and just log this, so we'll return the output. Now when we'll return this output, when we'll run the code, we should get 2468 as the answer. But let's see. So we are getting 2468. So this behaves the same way as the map function. So now instead of using map method, I can use mymap method, which can be executed, since mymap we have already defined and it's part of an array prototype. So I can use mymap method for using map in those browsers in which map method is not supported. Similarly, we can write the logic for filter also, reduce also, and the new stuff that is there. I think we are almost there on time. Let me see if there are any questions. I don't see any questions. So I'll talk about one last topic, which is promises. What do we mean by promises? We'll discuss that. So promises also has a lot of polyfills. We'll talk about that in a minute, like in a minute or so. So what is promises? Promises is nothing but you declare a promise object and you do new promise. Now it takes an executor function and it takes resolve and reject as an argument, and then you resolve it with some value, and or if you have resolved it, then you can't reject it again. Either you can resolve it or you can reject it. Now promise one gets access to your dot then or dot catch properties. Console log catch, maybe we will have some error. Console log. So I'll show you both the ways. Error. So when we when we resolve it, so one value should be printed. When we run this, we can see one is getting printed. Similarly, if you reject here with some error, you reject this with something went wrong. So we'll do one polyfill considering the time, because we started at I think 6:20 and I think 1 hour would be over. So when we run this, we'll see something went wrong getting printed, right? One is not getting printed because we've rejected the promise. Now there are a couple of promises. We have a promise called promise.all. Now what does promise.all do is promise.all takes an array of promises. You can define an array of promises and it returns you an array of promises, an array of fulfilled promises. If it is rejected, then it is completely rejected. We don't actually look for this. Once it is rejected, then it is completely rejected. If all of them resolved, then all of them are resolved. Now the order has to be maintained. We need to make sure that the order is being maintained. So here we'll try to implement a promise.all functionality, but let's see what does promise.all do. So let's take this example, which is given there in MDN. So you have promise 1, promise 2, promise 3. Promise 1 is getting resolved immediately. Promise 2 is a number which will automatically be resolved. There's no resolution part here. Promise 3 is also getting resolved within 0 seconds, right? Now when we run this, so see, the order has to be preserved, right? So here if I add if I resolve it after 100 milliseconds, still also promise 1 would be the first one in the array, and then the promise 2 would be there, and then the promise 3 would be there. So the order has to be preserved. Order is very important. Now if you have to create a polyfill for now if you want to create a polyfill for promises, what you will do is you will simply do you will create some dummy promises. So as we have created this one, we'll create a couple of more. Let's just remove this piece of code. I'm just going to show you how to create a promise all method or promise.all. So what you can do is function promise all. Now, as I said, it takes a list of promises. Now here const promise. We'll just copy this. And first we'll resolve all of them. 3, 4. Promise 2, promise 3, promise 4. We'll use resolve. We'll use resolve. We'll use resolve. We'll use resolve here as well. Then once we've used resolve for all 4 of them, we will pass some value here. Promise 1 resolved. Resolved. It's also a very important question from the interview perspective, asked in a lot of companies. So if you're aiming for front-end interviews, then do go through all these questions, because these are some of the important questions that are asked in each and every interview. So we'll just write numbers. Promise 4 resolved, promise 3 resolved, promise 2 resolved, right? Now here what we will do is we'll call our promise all method that we have defined, and in that we'll pass the array, and in that we'll pass all the promises, like promise 1, 2, 3, 4. Now, right now, all of them are getting resolved immediately. Let's add a set timeout so that they are resolved after some delay. So we'll add a delay of 100 milliseconds. Similarly, here also, we'll quickly copy this so that we don't end up wasting time. Let's copy this here also. Let's copy this here also. Promise to, let's make it 200, or let's make it 50, not this one, make it 200. Promise 3 resolved. Promise 4 resolved. Let's make this one as 20. Right now we have given promises in different order, 1, 2, 3, 4, and all of them are getting resolved after. So ideally, what should happen? The final array that we should get is promise 1 should be resolved first. Sorry, promise 4 should be resolved first, then promise 2, then promise 1, then promise 3. That should be the order. But here, in whichever order you are giving promises to the promises array, in that order we need to resolve. In that order, we need to push it in the output. It does not matter whether they are resolved first or later, it does not matter. So we'll start implementing this. So promise all returns a new promise. So when you do promise.all, it returns you a new promise. That should, so we'll return a new promise here. Now when it returns a new promise, we have resolve reject. Now here we will start traversing like promises dot, or we can simply use this loop for let I equals to 0, I less than promises dot length I plus plus. In here, when we have a promise, what we will do is promise I dot then and simple, if it's rejected, it will reject with error. So we'll simply reject the complete promise, reject with error, right? If it's not rejected, if it's resolved, what we'll do is we'll maintain an output array. We'll maintain an output, and in this output array, what we'll do is we'll keep on pushing these promises and the output of those. So what we will do is output dot push. We'll do output dot push. So we have promise I. So here what we are doing is, if it is resolved, whatever the response of this promise is going to be, we'll push that in the output response. And once we'll also take an index 0. So once, and we'll keep on incrementing the index. Once the index is equal to number of promises that are there in the array, we'll resolve it. We'll resolve with the output array. We'll resolve with the output array. Now here, if we try to run this code, for now, let's see what does it print. Response. When we response dot catch error, console log error. Over here, we'll just log the response. So promise is not defined. Where are we getting this? On line number 104. Okay, sorry, promises, it should be promises. So you can see we are getting promise 4 resolved, promise 2 resolved, promise 1 resolved. The same order which I was talking about initially, but this is not the order we should be maintaining. We should be maintaining the order in which it actually is inserted, like it's inserted in the array. So ideally promise 1 should be resolved, then promise 2, then promise 3, then promise 4. So how to preserve that order? Since we have this index, right? Since we have this index, so instead of doing that, what we will do is output of I equals to response, right? And now if we run this, so you can see promise 1, promise 2, promise 3, promise 4. Now we are getting the order as preserved also. So this is how you can create a polyfill for promises. Any questions anyone has? I think no, because I don't see any questions here on the chat. So yeah, these are polyfills. Like this is how you can create polyfills. This is how you can do function currying. This is how you can convert a multi-dimensional array into a 1D array. This is all what I was supposed to cover today. So thanks for joining this live stream. In the next week's session, we are going to cover some questions on React, which are asked in interviews. And post that, we'll talk about Node questions. Thanks for joining. Thank you, everyone.